Hello, welcome everybody.
Hello.
We appreciate you all being here. I'm looking forward to today's webinar. We're going to be presenting on optimizing preventative maintenance for maximum uptime. But as usual, before we dive into the webinar, let's review a few ways that you all can participate. So throughout the webinar, if you have any questions, you can type them into the little question feature you can see on that picture there. It's like a little circle with a question mark in it. Specifically, it's easy for us at the end of the webinar to go into that questions tab and read them all off. It's a little bit easier to filter them that way than in the chat. And then if you have any comments and you want to participate in the webinar, we are going to be asking you all questions during the webinar. If you have any comments or just any thoughts you want to share with everyone, you can post your comments in the little chat comment icon there. And then we are going to have time for Q&A at the end of the webinar. So we're going to be looking for all your questions in the question feature and in the chat. We'll try to filter through those. Okay, so now let's do our little practice time. Let's practice using the chat. So in the chat, let us know where you're joining us from.
We already got Carlos. We got Agnes, Canada. We got Greg Christensen. That's an Upkeep ambassador. Germany, Virginia, Wisconsin, Naples, Florida, more Canada, Trinidad, Texas, Iraq, Mexico City, Cape Cod. Dang, lots of Canadians in here today. Cali, Michigan, Buffalo, Texas. All the Texas boys always showing up. Tennessee, Pennsylvania, right up the street from me. All right, Oklahoma, got two people.
I don't see any Oregon people yet. Where are the Oregon people that are usually here?
I don't know. Nigeria, Texas again. All right.
Nice. All right. Well, I can see that you guys know how to use the chat. And it's really cool to see people from all over the world joining us. And we really do appreciate you spending this time with us. So I'm happy to introduce our speakers today, which does include myself and my colleague, Brian. Brian, can you introduce yourself and tell us a little bit about your maintenance background?
Sure. I'm Brian. I'm the Computing Partnerships Manager for Upkeep. Before this, I've been a heavy equipment mechanic. I've been a field service supervisor. I've been a maintenance manager, director of maintenance and reliability, and head of maintenance functions around the country. And I'm also a naval veteran. I was a GSC flight deck troubleshooter. But enough about me. Go ahead, Amissa.
Okay, so I'm Amissa. I'm the senior marketing manager here at Upkeep. I've been with Upkeep for over 2.5 years. I got my CMRP certification, so that's Certified Maintenance and Reliability Professional certification through SMRP last year. I will shout out Reliability X. If anybody here is from Reliability X, I did take those courses. I read Ramesh Jalati's book about maintenance and reliability best practices. And through those resources, I was able to take the CMRP exam and pass. So I got my certification. Also, a little bit of relevant experience I have is earlier in my professional working career, I worked as a manufacturing technician in a semiconductor plant. So I remember what it was like from an operator standpoint to run equipment and machinery, and then what would happen when the assets went down. It was a big deal when we had unexpected downtime in the factory. So I have a little bit of experience there. Let's dive into the agenda for the webinar. So for today's webinar, first, we will do an overview of preventative maintenance, just to kind of level set with some of the basics of PM. Then we're going to talk about some of the challenges associated with it. We're going to dive into some of the core principles. We're going to talk about effective PM scheduling, optimizing resources. We're going to talk about some KPIs for PM, and then we're going to wrap up with some real life PM success stories. And I'm going to say PM instead of preventive maintenance because it's just easier. So when you hear PM, that's what I mean. All right, Brian.
All right. Thank you, Amissa. So we're going to start off with some overview, some challenges of preventive maintenance, okay? So the overview, what is preventive maintenance? It's a proactive approach designed to keep equipment and assets in optimal condition. So you're maintaining, right? You're maintaining the designed reliability of a machine. keeping it within its design context, doing all the right things that are involved proactively to ensure that you have effective maintenance tasks and efficient maintenance tasks, and all of that lines up with a long, prosperous life of that piece of machinery. So, all right, common PM challenges. So, creating and running effective preventive maintenance program comes with several challenges. Here are some common ones: high initial costs, lack of data, resource allocation, skills gap, performing the wrong work, difficulty measuring return on investment, and getting buy-in across the organization. So, what is your biggest PM challenge? Type it in the chat. I'm going to harp on performing the wrong work. Okay. 9 times out of 10, when I audit companies, they're doing a lot of work that is non-value adding. They are also stuck in this dichotomy of, when something breaks down, senior leadership wants to know more PMs, do more PMs, right? When in reality, we should be doing the right PMs at the right time on the right equipment with the right resources. So I'm going to harp on that one. Part of this is talking about task creation and defect elimination, and we'll get into those things. But let me know, what are yours? Schedule, huge one. Yeah. Duplicate PMs, huge one. You need to get your data integrity going for that. Doing it too soon. Yeah.
Not in the right timing. Yeah.
Not the right time. Return on investment. The best thing with return on investment when it comes to preventive maintenance, ask senior leadership, do you want your machines to perform their function when you want them to perform their function? If they say yes, then you say, all right, you got to let me do preventive maintenance.
Not having parts on the shelf and lack of schedule. Yeah.
Schedule is always going to be a huge one. Scheduling takes so much initial resources, right? It takes either designating a specific person, getting them ingrained into the operation, into the maintenance, and how long jobs take, what resources are needed. It's just a lot to start. Work on critical assets. Yeah. That's why we have an asset hierarchy, and then we have a criticality analysis, right? Yeah, Greg, that's right. Yep. OEM. The OEM is not always right. Hear me say it again. The OEM is not always right. They're looking for one of two things: to sell you a bunch of spare parts, or wait till your machine breaks so they can come in and do fixing or retrofitting. All right, moving on. All right, what are the core principles of preventive maintenance? All right, so we want to do regularity and consistency. Maintenance tasks should be scheduled and performed at consistent intervals. However you decide to do that. That can be time-based. It can be usage. It can be condition and context, right? So we have to have consistent application of these tasks to help prevent degradation, extend the lifespan of equipment. However you or your organization finds the most meaningful way to schedule work, okay? Time, usage, condition, context. I will say this, that condition and context will put you closer to optimization than others. But there are some regulatory PMs and services that have to be done time-based so that you can meet your requirements. Okay. All right. Next one, prevention, not reaction. Of course, that makes sense, right? We want to be proactive in our approach, preventive in our approach, and not reactive. So the primary goal of PMs is to address issues before they become significant problems. We want to talk about wear and tear. We want to talk about minimizing the likelihood of unexpected failures, reducing unplanned downtime, right? PM tasks should be aimed at addressing known failure modes. I'm going to say that again. PM tasks should be addressing known failure modes, not look at belt, check pulley, look at frame. That's not a task. So we need to be directing those tasks, and we'll talk more about that. All right, tailor plans for each asset. That kind of goes with what I was just saying earlier, right? But not all equipment requires the same maintenance schedule or the same maintenance in general. So tailoring your PM to specific needs, criticality, and operational conditions, ensure efficient use of resources and reduce unnecessary maintenance. The key there is unnecessary maintenance, right? If you have 2 conveyors, but they're in 2 different contexts, they're the same conveyor, but one's in a coal plant and the other one's in an aggregate plant, okay? There's going to be different failure modes. And we need to make sure that the PMs are written to address those specific failure modes based on the context. So we want to have a tailored strategy for each individual asset. Now, if you have 15 forklifts that are the same exact model, make, they're just running around a warehouse, then you can probably spray the PMs across all of those and not have to divvy them up separately, right? You guys get the picture. Documentation and record keeping, of course, this goes without saying, right? We want to make sure that we track all of our critical stuff, all of our crucial stuff. We know the performance, we understand the failure trends, and we want to improve the overall PM program by leveraging all that information. So we want records to allow us to drive data-driven adjustments and defect elimination. PM, you should just think about preventive maintenance and defect elimination being synonymous, right? Yes, they are different things, but when leveraging defect elimination tools within your preventive maintenance program, you are more likely to get ahead and do the right work. Okay, huge one, PM task creation. So this is where we get down to the meat of it. What should I be looking for? How should I be making tasks? Should my PM say check belt? No, it shouldn't, right? All right, how do we break this up? How do we prioritize tasks, right? By categorizing tasks with clear priority levels, teams can ensure the preventive maintenance focuses on the most impactful areas. We want to balance regular intervals with condition-based needs. This prioritization also supports better planning, resource allocation, and minimize likelihood of failure. So when we're developing our tasks per PM, how do we prioritize them? We want them to be meaningful. We want to take in criticality. We want to take in likelihood of risk. We want to take in all the things. We want to talk to the technicians, the engineering team, the safety team. What is important? And how should we be uncovering potential failures and know what good looks like or what bad looks like? So continued, here are some things to take into consideration when prioritizing your tasks, right? With calibration checks, some things are for compliance, right? Certain machines have to be calibrated, stamped, maybe even tagged. Sometimes those things are regulated by industry. We talk about lubrication tasks. Like lubrication is one of the biggest bangs for your buck that you can get from an application standpoint. Adjustments, part replacements, condition-based adjustments, right? So we want to make sure we're looking at all these different categories and prioritizing that work, right? And it's best to bring everybody into the conversation when we talk about this. If you have lube techs, right, specifically, bring them into the conversation. If you have production engineers that are dealing with capacity and ensuring machines are operating efficiently and things like that, bring them into the conversation, right? We want to talk to those people so we can prioritize the tasks that we're going to create for our preventive maintenance strategy. Is there any chance we can see the slideshow bigger? Shows a fraction of the screen. What does it look like to you, Amissa?
I only see the slideshow.
But you can see PM task creation and defect. Mm-hmm. You can see everything, right?
Mm-hmm.
I'm sorry, Juan. I don't. He said there's 3 videos running at the same time.
Yeah, I think you're okay from what I can see, Brian. But Juan, we can send you a copy of the deck afterwards too if you want to look at it.
Yeah, this will be available to you guys after the fact. All right. So this is the nail on the head here, defect elimination, right? All of our tasks should be aimed at having some form of defect elimination process. So it's a proactive effort aimed at addressing and eradicating potential risks or failure modes. It involves identifying and understanding what good looks like, right? The ideal state or standard of operation, and then systematically working to eliminate defects or deviations that put that at risk and lead to failures. We have to have a clear picture of optimal performance and target interventions effectively. If you know that this one machine in this capacity is what it should be doing, the right speed, the right load, the right amount of lubricant, the correct belt, whatever. We want to know what that is, and then we want to keep it that way. So any defects that show their face, we want to address those things to keep it in that context of what good looks like. By performing tasks that are directed at failure modes, you will eliminate them. You'll be doing tasks, solving problems, maybe changing out the design of a bearing or a pulley, or you find the root cause of an issue, right? And you correct it. Now that task can go away. That's a defect elimination. That's the whole story behind fixed forever and not forever fixing. And then, of course, we have to have a feedback loop. So we want to know what's going on. so we can make those adjustments. Our defect elimination is essential for continuous improvement. As defects are identified and eliminated, the insights gained should inform modification, preventive maintenance tasks, and strategies. Super important. We got to know where we are and the successes that we're having. How are they impacting our preventive maintenance strategy? How are they impacting the uptime of the machines? And then we modify accordingly. If we're doing a whole bunch of PMs and we still have a ton of unexpected failures, downtimes associated with those machines, we're probably doing the wrong work, right? So we want to analyze root causes, determine underlying reasons for defects or failures, adapt PM tasks. Of course, we want to modify and change as we go along. And then we want to redefine the way our maintenance strategy is. It evolves over time, right? Based on age and intervals and context. We want to make sure that we can have the associated resources there as we're getting that data in. It's dynamic, right? And PMs, they're a living document that ages with the age of a machine and the context of a machine. So keep that in mind. PMs are not set and forget. They're a meaningful strategy to have you looking into the way the machines are operating, being maintained, and ultimately, what are we doing to ensure that they're going to see their useful life? Defect elimination is a massive part of that. All right. Developing effective PM schedules. Okay, of course, asset inventory and classification. We've got to have some sort of hierarchy, criticality, all that stuff. We want to have, our histories. We want to have, skill sets, all the things associated with understanding the asset. That all comes from your CMMS. All that data should be in there. So that's going to help you prioritize maintenance for the high impact assets, all your critical or any kind of machine or component that experiences high probability, high impact failure modes or low probability, high impact. Although it is low probability, it can have a massive impact. We want to make sure we can address those things. Okay, establish baseline performance data. Review manufacturer recommendations and historical performance data to determine appropriate maintenance intervals each. So the key there is to review historical performance. If you don't have a CMMS or you don't have that data, go out on the shop floor and talk to the technicians, talk to the operators, talk to the maintenance manager, talk to the safety people, talk to anybody who is involved or around that machinery when it may or may not break. They can provide insight to you if you don't otherwise have that data. Take that, align it with manufacturer's recommendations, and then you'll start to see a picture of where your resources and things need to be done. And then you can start building from there. So this is your baseline, right? Okay, so we want to determine task frequencies based on asset classification, which is your criticality. How important is it? Do you have a hierarchy based on system or component or part? Like, how do you identify those things? And then we need to establish how frequently we perform those. And again, we talked about in the beginning, time-based, usage-based, condition-based. If you are putting machines outside of their design categories, outside of their design context or environment, your intervals are probably going to change. You're probably going to have to do some things that are probably not warranted on other things, right? Because you're taking that machine out of the reality of its context. Automating scheduling where possible. Of course, we want to use our CMMS to automate scheduling, reminders, task assignment, getting people aligned with the work that needs to be done, when it needs to be done, and who's involved. And that takes away the human error of having somebody constantly trying to send schedules out and, all that type of stuff. So we're reducing variability there. Okay, question for you guys. What factors do you use to determine PM frequency? Do you use time, usage, condition? Do you use telematics if you're in mining? What do you do? Put it in the chat. Time and usage, no worries. Mix, but mostly time. Time, super common. Yep, time's a big one. Good. Now, my challenge question is this. Oh, there we go. There was the winning answer. Time based on failure frequency. I was just about to say that. How many people take in failures to associate to your time-based maintenance, right? So if you're maintaining something every month and you realize that failures are popping up every 3 months, well, maybe you should do a PM every 2 months and have a task in there that's to eliminate whatever that failure mode or mechanism was. So we're paying attention to failures in association with our time. Condition-based maintenance. I love condition-based maintenance, and don't get caught up on condition-based maintenance only being sensors, right? Condition-based maintenance could be a well-written inspection that you do while the machine is in operation, meaning you're taking measurements, you're looking at capacity, you're looking at, how things are operating, all that stuff is condition-based maintenance. And by having those specifications against a known correct standard, is that knowing what good looks like, right? So then you can start to build out against that. It doesn't have to be a sensor or whatever. It can be a person taking all these measurements as well. Okay, review and adjust regularly. We talked about that. It's so important to use all this data as a feedback loop. You got to know when to adjust the schedules based on failures. You got to know when to adjust the schedules based on resources. You got to know when to adjust the schedule based on how often you're doing maintenance. Are you getting effective uptime from the work that you're doing, right? So constantly review and adjust. Okay, resource allocation. All right, prioritize critical equipment. We said that, very important, right? We want to focus on critical equipment of your operations. High priority assets should receive most insightful strategy and result in significant downtime or financial loss. So take that not for what it says, take it for whatever is meaningful to your business and your business has agreed upon is bad. Whatever that is, those are the things you need to be prioritizing. It could be anything. It doesn't have to be what we're saying here. It could be whatever the business agrees is a big problem. It could be environmental health and safety issues. It could be compliance issues. It could be standby labor cost. It could be the missed opportunity costs associated with things. So it's whatever you guys deem critical. Don't get caught up in all the nonsense and words and what people tell you and stuff like that. Balance the workload. This is a huge one, right? We want to distribute maintenance tasks across your team to avoid overburdening individual technicians and to make the best use of their skills. So what's super important, and your planners, your schedule, I think I said this last webinar, is have your planners, schedulers, maintenance leadership, have them know your skill sets through a training matrix. What technicians are on shift this week and this day and this time? What are their specific skill sets? You're tooling up the planner and the scheduler and whoever else, the maintenance supervisor, to know who's around, who has the skills, and how can we best allocate the work, right? Everybody on this call has an ace mechanic that works for them, or technician or electrician that you're like, man, I just want this guy to do everything because I know it'll be right. Unfortunately, that doesn't always happen. We can't do that, right? So get everybody trained up, have a training matrix, know where everybody stands, and be able to utilize that distribution of load across everybody. It'll be happier technicians. Everyone will get their cross training, all that stuff. It can only be beneficial. Standardized maintenance procedures. So this goes without saying, it's just like task creation. We want to standardize the way we create our PM tasks or our schedules, right? We want to make sure that if Billy comes in and Billy's only been here for 2 months and Johnny's been here for 10 years, he can perform the same task. Maybe they don't have the same skill sets, but they can follow the same task instructions. That's the key here. He's being able to follow the task instructions. Will he need help? Probably. But you should write services to which the most green person can read and understand them. So that means adding pictures, specifications, drawing things on pictures and say, look at this thing, giving a specification, right? What should it be? And I keep going back to it. What does good look like? Super important. All right. And implement condition-based maintenance tools, right? Leveraging condition-based maintenance. You guys know all of them, right? You can optimize both labor and materials by anticipating times for maintenance. If you don't need to touch something all the time, or maybe it's in a risky situation, but you want to keep an eye on it, talk about implementing condition-based maintenance tools. Stock management. You can't maintain stuff if you don't have what you need. Just simple as that. If you're setting schedules or kitting parts, or you're planning work and you don't have a spare parts inventory, you don't have a way to understand what's there, what's not there, what's been consumed, what's in holding to be consumed on future work, then you're going to have some troubles. So having a well-organized stock management is going to create efficient use of those resources for preventive maintenance. All right, KPIs. I know you guys all love these. All right, schedule compliance. Very, very simple, right? Basic. KPI shows all of the maintenance tasks are completed on schedule. High compliance means your team is following PM plan effectively. Now, don't get caught up with this, because you could be very compliant, but be doing the wrong work. So this is not an indication of uptime or defect elimination, anything. It's just showing you that the PM's plan, their scheduled times and completion times are correct. But the most important thing is we want to make sure we're doing the correct work. Planned maintenance percentage. Okay, this is the percentage of planned preventive maintenance in your maintenance hours, right? So if you got 100 hours in, let's make stuff up, 100 hours in a week, and it's 98 preventive maintenance hours, that means you have 2 hours of or planned maintenance, you have 2 hours of unplanned maintenance, right? So it's super simple. Again, this is measuring time spent on tasks, not necessarily are those tasks valuable, but these things do point you in the right direction to help build the culture to start driving more meaningful conversations and change within this whole overall strategy, just like schedule compliance. Of course, the obvious one is mean time between failure, right? Tracks the average time an asset operates before it fails, increasing MTBF suggests your PM practices are effective in preventing breakdowns, right? So that's like your reliability metric. Again, of course, mean time to repair. This is more of a resource, right? This is measuring how competent and the resources associated with your downtime, right? How long does it take to get that machine back into operating context, right? So it measures the average time it takes to repair equipment after a failure. So a low MTTR means that repairs are handled quickly, minimizing downtime. Again, that speaks more to technician skill set, resource allocation, and operational alignment than it does anything else. Okay, here's a good one. We've talked about this before, maintenance cost per unit of production. How much are you spending on maintenance per unit produced, right? You're setting out 100 widgets an hour and they cost $1,000, but you're spending $2,000 an hour on a breakdown, right? So you're in the negative there. So we want to make sure that our preventive maintenance tasks and strategy keep a super, super efficient cost association with repairing those certain machines. So it's cost per unit equals total maintenance cost divided by units produced. So we want to keep that in step. And here's my favorite one, especially for all you guys building a strategy and you really want to know where you stand. This is corrective work order generation. So the KPI tracks how corrective work is generated from your PM tasks. Corrective work is an indicator that your PM tasks are directed at failure modes. Super important. So it's a lagging indicator, yes, but it does allow for a lot for course correction. If your PM tasks are generating a high volume of corrective work, it is an indication that defect elimination is required, meaning you're doing the same work over and over again. We should be looking at why we're doing that work, find the defect, eliminate the defect, stop doing all that work, okay? And on the flip side of that, if your PM tasks are not generating corrective work, then PM reevaluation needs to be directed at potential failure modes. That's how we would advise that. You're not generating anything. Well, it's probably because the PM is look at belt. Okay, I'm looking at the belt, but it doesn't tell me how's the tension. Is it a synchronous belt? Is it a V belt? Are the cogs jacked up? Is it cracked? Is it pitched? Is it straight? Right. So those things, those types of tasks will become your guiding light into defects, right? And then we start to eliminate. So this is the basis of defect elimination. You do preventive maintenance work based on the tasks that are in that preventive maintenance work. Are you failing those tasks because you're uncovering issues? If you are, there's corrective work being generated from that work. We measure that and we know how valuable or how wasteful our PM tasks are. All right. This is Amissa. Go ahead.
Yeah, okay. So we're gonna get into Q&A shortly. So if you guys are having any, I do see some questions in there already that we'll address, but right now is a good time to type any questions you have in the chat so we can talk about those in a couple minutes. But before we get there, I'm just gonna touch on a couple upkeep customer preventive maintenance success stories. We have a few here, but I'm just gonna do a couple so that we have plenty of time for Q&A. So first customer, they are a food and beverage packaging company. They were using an antiquated maintenance management system. It was slow. It was difficult to use on a daily basis. They had to manually allocate tasks. They had to, and the tracking of the workload was difficult. They also had difficulty tracking the progress of jobs. They were manually inputting PM paperwork and duplicating what they were doing. So basically, they were wasting a lot of time with a system that was not efficient. And then the engineering manager told us that whether they were using desktop or the mobile version of their old system, it was really slow, and that setting up the system was difficult with many steps. They said it would take them way too long to raise a preventative or reactive maintenance task, and that it was costing them a lot of money. So they wanted to have the ability to create preventative maintenance work orders as well as store and access inventory data easily. They implemented Upkeep, and then they were able to instantly attach images, PDFs, manuals, documentation to their work orders and manage the team. Also, their team and their management receives digital notifications anytime a work request is made, and then when progress was made and when it was completed. They also told us that they love their KPI dashboard. So they had a custom KPI dashboard made, which allows them to dive in and run reports that they need. And within 30 days, their team was able to get insights into their maintenance activities, such as work order completion by asset and technician, and monitor KPIs like preventative work order completion rate, as well as work order response times in Upkeep. So now they have improved their team productivity, they have better visibility into their PM tasks, and are more proactive management of their equipment health.
Nice.
Yeah. And then this one is a little bit of a different scenario. So they're actually, they run several high-end restaurant locations, and they're using an inefficient system for their maintenance department specifically, which was difficult and provided limited access and visibility. So as a result, when upper management wanted to understand what was happening within the maintenance department, they had to make dozens of calls and sort through paperwork. Not to mention understanding patterns of issues it was very slow and difficult. Making business decision, being able to make better business decisions was very difficult and cumbersome. So specifically, they were having issues with one of their high-end restaurant locations, the freezers and coolers that were holding expensive Japanese Wagyu beef, if you've ever had one of those steaks.
Delicious.
No one at the restaurant had realized that their cooling system had gone down, and it cost them about $15,000 in food spoilage. That's a lot of spoiled Wagyu beef. Then they implemented Upkeep. So they did the Upkeep maintenance management, and then they also did Upkeep Edge with temperature sensors, and they started a condition-based PM program where they were monitoring the freezers and coolers at their locations remotely so they could prevent versus react and base their PM tasks off the condition of their equipment. So now they catch failures before they happen. They can also see which machines are being serviced more and can follow that history. And they also can manage preventive maintenance more efficiently because they can easily see what is causing more problems and make their PM program adjustments as needed. So after starting the CBM program, they were able to see that one of their cooler's temperature was rising rapidly and past the warning threshold that they had set. And then they were able to go out immediately and address the issue before losing product like before. So in this specific case that I'm telling you about, they prevented $8,000 in food loss.
Nice.
Yeah. So there is a couple more examples here of PM success, but let's go ahead and skip over to Q&A because I like to have lots of time for that.
All right. Conclusion is preventive maintenance is important. Do defect elimination, talk to people, bring people into the process, write tasks as if you're writing them for someone who doesn't understand, give pictures, give examples, schedule them based on the resources that are most appropriate, have a training matrix, and ask questions when you don't know things. That's this conclusion.
Okay. I'll start reading off some of these questions in the chat here.
All right.
One that I see, John says, is there a way when in the PM to see the parts history of when things were replaced, or is it having to go through all the old PMs to find out? For example, HVAC filters or emergency light batteries.
Yeah, so it depends on what CMMS you're using. And Upkeep, you can go to the asset tab and you can see what parts have been consumed against that particular asset. Or you can go to the part tab, click on the part, and that tab will tell you what work orders that part has been consumed in.
Mm-hmm. Okay. Let's see. I'm looking for the next question. Scrolling. How do you handle when a technician stands out in certain tasks? So I think he was asking when about resource allocation and not overloading certain technicians over others. Are you able to identify preferred technicians? Sometimes all technicians are equally qualified, skilled, but in practice, Billy is very good at task A and John is awesome at task B.
Yeah. So this is what I would do. That's why we talk about a skills matrix. In all the buckets that the technician's skill sets are ranked, have a slash or a separate portion that is application knowledge and grade them on their application knowledge. If it were me, I would color code them. So when a scheduler or a planner is looking at the skills matrix, they know, yeah, Johnny and Billy can both do task B, but Billy's on shift and he's better. So I'm going to use him. But if Billy wasn't on shift, I know that Johnny is equally or a little bit less, but he can still get the job done. So I would make sure your skills and your training matrix reflects application knowledge, not just theory. So for me, what I would do is I would have all my names of my technicians, the different buckets of training that they've taken, the date, and then also their ranking in it, whether you grade them by A, B, C, or D. And then you would have a slash. So the first letter would be their theory trained. The slash would be their application understanding. And they may be different, like you said, which is 100% true, but at least gives you a direction to have your planners and schedulers understand who should be doing the work.
Cool. I don't quite understand this question, but I'm going to read it. It says, does Upkeep work with JDECAM?
Yeah.
I know what CMMS is, obviously, question mark.
I think it's JD Edwards.
Okay.
Yeah.
So is it integrating? Is that what they're asking?
Yeah, I don't want to speak to that. If you are genuinely interested, we can get to those answers for you, but I don't want to speak to it because I'm not 100% sure. So our best people to talk to would be our customer success team or our sales team or whatever. They can point you in the right direction.
Or I put our emails in this chat too. If you have questions, you can always email us and we can either we can help you directly or we can get you in touch with a person that can help you for sure.
Yeah.
Does Upkeep let you put picks in the tasks? Like if you're doing a work order?
Yes. So no. So there's two answers to this. Mm-hmm. Okay. So if I create a PM and I add a checklist to it, the checklist has individual tasks associated with it. Right now, the technician, when he's interacting with that task, can submit a picture associated with that task. Okay. As far as putting pictures in the task proactively, meaning that you're going to give them to the technician as they look through the task, no, that is coming. But the workaround for that is through your PM schedule, you can add pictures to the PM schedule, and then you can associate the tasks with the pictures. It's not as streamlined as having the picture right on the task. If you're an Upkeep customer and you're interested in that, we can show you how to do that.
Okay, let's see. How can I keep control over my spare parts stock? Can I assign specific spare parts to specific assets? Would be available to others eventually in the system? Question mark.
I don't understand the last part, but yeah, you can assign spare parts to specific assets, or you can not assign them. You can leave all the spare parts could just be there, and you search them as you want. But you can assign specific parts to specific assets. And I'm pretty sure you can. I'm speaking from Upkeep. I'm pretty sure you can put a bunch of different parts associated with an asset.
Mm-hmm. Yeah,
and you can associate single parts with multiple assets.
Oh, here's another product-related question. Do you have a mobile app, and can they be created in multiple languages for the same task?
I think so. Peyton, you should. Yes, we have a mobile app. We were the first mobile-first solution. Don't get it twisted with anybody else. So let us get you in contact with our sales team. Our app comes in like 15 languages. Like it can literally use the phone's like language preferences to use in the system. So I'm fairly certain we can do those things, but we get you contacted with sales, and they can definitely give you an answer there.
Yeah. Okay. Well, this is a longer one. Do you want to read that, Brian?
Yeah. Let's assume the following scenario. In a production facility, if plant A maintenance has been planned to take place today, but due to business dynamics, management decides to continue running the plant A, and in lieu of that, give you the opportunity to carry out maintenance on plant B. That was already scheduled to come up originally in about 6 days. Can we say there is compliance for that plant B? Just change the due date. That's why you have a supervisor or a planner or a scheduler. When that work comes up, it's due, it's popped, it's been scheduled, it's put in place to work, and that day of they go, hey, we can't do that. Reschedule it, put it back in the backlog. That way you're not messing with compliance at that point. Right? It'll fall back into the next scheduled run, and then you'll be compliant with that next schedule. And if you're 6 days ahead on plant B, then you would just be closing that work order out early. And then you would just, the next reoccurring work order should just be minus 6 days. I hope I'm making sense with your question.
Okay, let's see if I can find any more questions. We got a couple minutes left. Let's see. Well, there's some up here. I can't find them. It's hard to find the questions in the chat there. Do you see inspections of equipment as a standalone PM to inform the overall PMs for each piece of equipment?
Yeah. So, for instance, I've written many PMs that are like your daily condition-based walkarounds, right? So, in between actual PMs where you're stopping equipment, changing parts, doing in-depth inspections, I used to write what were called active inspections, and they were inspections written to address and understand the operating context of a machine without taking it out of operation. So yes, we used to write them all the time. They were called active inspections, and they were normally sprinkled in between like bigger PMs that would involve taking the machine out of context. Because what you do is when you're measuring and you're looking at all these different things, you can start to create corrective work to then add to that preventive maintenance once the machine is already down, or schedule it for another time.
Okay. All right. Well, we are running up on time, so we're gonna cap it here. But I'm gonna type our emails into the chat here real quick. So feel free, if you want to continue the conversation, you can email us. If I can find them, where to go.
Thank you all so much. Also, too, if you want to provide us some, Amissa can help me here. But if there's a way they can provide feedback into webinars, what they might like to see, Amissa, is there a way for them to make a suggestion there?
I would love if you guys had specific challenges or struggles that you're dealing with on a daily basis that you'd love to see an in-depth webinar about. Then yeah, email me that. Email me your suggestions as well, please.
Cool.
All right. Thank you all very much.
Thank you all so much.
We'll see you soon at another webinar. We appreciate you.
Thank you. See ya. Bye, Amissa.